So we're going to continue basically with our normal distributions and our standard deviations and stuff, right? So remember how before what we're doing is, you have the normal distribution, you've got your mean, and then you've got the standard deviations here, one standard deviation up or two up and so on. And then we would say, okay, so like, how many are between 59 and 69.5? But all of those fell on actual multiples of the standard deviation. Now, suppose you kind of had to look at it a different way and just sort of say, if a value is here, like 63, right? This is between 1 and 2 standard deviations, right? But do you know exactly where it is? It's somewhere at like 1.3 standard deviations. That's what z-score tells us. It tells you exactly where it is, like how many standard deviations away from the mean a number is. Okay? The formula for it is really, really simple. It's called z-score, also standardized value, but it's always referred to as z-score. And again, it's the number of standard deviations that a given value is above or below the mean. Okay? This is how we calculate z-score. So basically, what are these players here? You've got the value minus the mean over the standard deviation, and you have to round to 2 decimal places. Okay? All right. So let's find some values here. Okay. We're given x is 24, x bar is 29, sigma is this. We need to find z. Okay, so we say z is x minus x bar over sigma. Okay. The order really matters here, because if you did x bar minus x, then you would get a negative versus a positive, and that makes all the difference, because if it's negative, it's below the mean, positive above the mean.
So this one would be below the mean?
Yes. So this one here, we have 24 minus 29 over 4.2. This is a z-score of negative 1.19. Okay? All right. So let's see if that makes sense. So you see the normal distribution here. The mean is 29. The standard deviation is 4.2. So if we go down 4.2, if you go down 4, that's 25. So 24.8, that's 1 standard deviation. Okay? We're looking at the value of 24, which is here. So do you see how from the mean, it's 1 and 0.19 deviations away, standard deviations away? That's what we have just found. Okay. Next, we are given z and x bar. We need to find x. Same formula again. Z is x minus x bar over sigma. Z, negative 1.73 is equal to x minus 48 over 2.3. Okay? You need a calculator. You all need your calculators for what we're going to do later as well. Multiply by 2.3. Okay, so some algebra. X minus 48 is negative 3.979. What do I do next?
Negative. Wait, what is it?
So if x minus 48 is this,
You add 48.
add 48. So smaller, 44.021. And okay, so you're looking for x. Z-score, we go to 2 decimal places. X and x bar are buddies. They need to have the same number of decimal places. Since x is given as a whole number, round this to the whole number. Okay, so round to same place as x bar. Okay. Okay, example 4. For some reason, like the space went away. So I'm just gonna have to fit it in that tiny little space. Okay, consider a comparison of two individual data values as we try to determine which is more extreme. On the one hand, you've got a person's height of 72 inches. And on the other hand, you've got the person's weight of 237.1 pounds. So you want to know which of them is more of an extreme value compared to the mean. Okay. You can't compare the two of them to each other, right? Because it's like weight and height. It's like apples and oranges. However, you can find each of their z-scores and see which one is more away from the mean, is further away from the mean. So look at what we've been given here. You're given that heights have a mean of x bar and a standard deviation of this. Weights, same. Okay, so ZH. So let's find the Z for the height. 76.2 minus 68.34 over 3.02, 2.60. So that height is 2.6 away from the mean, 2.6 standard deviations. This one, Z of the weight, it's the X value minus the mean, 172.55, over 26.33, 2.45. All right? So which one is the more extreme value? The height, because it's farther from the mean than the weight. Okay? All right. For what we're going to do next, you need your graphing calculator, so let's go ahead and take those out. Okay? What we want to find are the interval of z values. Interval means a range, right? Okay, we're going to write down the process. It's not that much. So look at the first one. You want the z values for the middle 50% of the data. Let's draw ourselves a normal distribution. And let's section off the middle 50%. That's the middle 50%, right? You want the z-scores there and there. So basically, you want to know what this z-score is and what that z-score is, right? The median is somewhere in the middle here. I'm sorry, the mean. Okay, so if that inner portion is 50%, how much is left for the outer portions total? 50%, but it's split evenly, so on each side you have how many percent? 25% and 25%. Which means if I start from 0% on the far left, by the time I'm at the first red dot, what percent have I reached? 25%. Which is 0.25 in decimals, right? Now, from the 25%, if I move further to the right, an additional 50%, by the time I'm to the second red dot, how many percent is that? 75%, which is 0.75. Okay? Bernie. Okay? Those are the two numbers I need. Okay? This is what we're going to use to put into the calc. Okay? Input values. All right. So, On your calculator, let's go to a new screen.
Just calculate.
Yeah, just a calculator screen. Okay, so we're gonna press menu, statistics. Okay, so menu, number 6, statistics. Then number 5, distributions. After that, number 3, inverse normal. And here, you're going to put in your decimal values. So here, enter decimal values. Okay, so first let's put in the first one, which is 0.25. Oops, 0.25. Press enter twice. And look, you've got that number, negative 0.67. This is a z-score. So how many decimal places? 2. Yes.
Sorry, do you mind just going back? I was.
Yes.
Yeah, just how you plug them in again.
So this, hang on, this is negative 0.67, and we're going to do less than or equal to symbol. So less than or equal to z, less than or equal to, now you're going to do the process again. Menu, 6, 5, 3. Now the second number, 0.75, 0.67. Okay?
It's not 90.
Not right. So because it's symmetric, right? And each of these numbers represents how far away you are from the mean. Well, it makes sense that you're the same amount away to the left that you are to the right. Okay? Now, because we were looking at how much is in the middle, in that bounded area, this is a bounded inequality. Okay? Less than or equal to, less than or equal to, right? Because my boundary, right, it goes towards each other like that. As opposed to the next one, where we want the outside 20% of the data. So let's draw another distribution. The outside 20%, this, okay? Again, it has to be symmetric. So how much is in each side? 10% here, 10% here. So how much is in the middle? 80%. Now, okay, by the time I'm at this point, what percentage have I reached? 10%. And then by the time I'm at this point, what percentage have I reached? 90%. Right? Is everybody clear on that? Right? So from here to here, 10% plus another 80, so now I'm at 90%. Now, this is 0.1 and this is 0.9. The difference, however, is this. The regions that I want now are disjointed, right? This is not a bound inequality. This is an or inequality versus an and inequality. So it's going to be, z is less than or equal to some number, or z is greater than or equal to some number. Okay, let's put in our numbers. Okay, by the way, you don't have to reinvent the wheel. Once you're here, you can just press the up button once, up button twice, highlight this term, the expression. Press enter, and then just go ahead and edit. So I want to make this 0.1, negative 1.28, or edit again, 0.9, positive 1.28. Okay, so that's the answer. Okay, do you see how it has to fit the description, right? It's a disjointed region, so it's either underneath that line or above the second line. All right, there's nothing in the middle. So the concept of it is rather straightforward. You just have to make sure that you do the configurations easily. Okay? All right, let me stop this here.
How'd you copy it again?
And you can do the homework.